Right, we're going to look at what characterization tests are and why we need them. And as a bonus, I'm going to look at what we should be doing with them once we've finished all our refactoring. You may have already seen me use characterization tests within my refactor videos, and that's because it is a genuine first step to dealing with any code base that has no tests or inadequate tests. When you introduce unit tests, normally you don't chase code coverage, but when you add characterization tests, you should be looking to get 100% or as close to 100% code coverage as possible. And this is the only scenario I would ever advocate for you chasing code coverage. There are a couple of principles I hold myself to when writing a characterization test suite. And they are simply, all the tests must assert an expected output or state given a specific input or initial state. And the second is that each code path is covered by multiple tests using as many different scenarios as conceivable.
Inconceivable!
And this is so we can be absolutely comfortable we've got most of the code paths that we're likely to change covered before we go in and make a massive. To explain what characterization tests are, I'm going to take an example from real-world engineering. In physical materials terms, a characterization test is very much like a jig. So what's a jig, I hear all but one of you ask. A jig is used to maintain distances between key points while doing fabrication or a repair. And that's because materials tend to distort under large quantities of heat. And activities like welding, grinding and drilling tend to produce a lot of heat. In a very test-driven development way, a jig is built before the piece of work that it's there to support. And much like our unit test, it's designed to be something that is dependable. It's built to be very rigid and to withstand much more abuse than the piece of work that it's there to support. We want that from our characterization tests. We want them to be dependable and useful while we're doing that refactoring. And the number one reason for having characterization tests is that we are human. We make mistakes. We do crazy things in code and end up in a big mess.
Well, look, guys, it was my first day, and I was nervous, and I was hurrying, so...
Really? That's why you decided to write the slowest subroutine in history?
Having characterization tests to fall back on means that we can get back to a point where all those tests are passing and we're comfortable that everything is working as it did before. When we go in to make changes, we often assume that a piece of code works, and it often does. Even when we create the characterization tests, we're making that assumption that the piece of code works, but we don't know of any defects that might exist. The characterization tests are there to help us change that piece of code into something that is more understandable, that will then allow us to make more significant changes in the future. If you're kind of crazy like me and you've kind of wondered what an agile process would look like if you adopted that in a real-world fabrication context, then I've put a link to a series that is worth a watch if you have the time, called Project Binky. And the one thing in that you'll realize is that the amount of time and cost of change within that real-world fabrication context is huge compared to the relatively low cost of change within software development. Now that brings me to a key point. We can change things in software like that, and that is the soft in software. And with these characterization tests, we really should be looking to replace them with something more meaningful once we have a better understanding of the expected behavior of that piece of code. And that task is not high cost, so we should actually be doing it. We shouldn't have a second thought. It should just get done. If you're looking to test or refactor a legacy code base, then characterization testing is a must-know technique. If you're interested in learning a bit more about working with legacy code in general, I'd advise getting a copy of this book by Michael Feathers, Working Effectively with Legacy Code. You can also read this book on O'Reilly's online media platform, and I'll put links to both of those in the description below. So once you've got a complete test suite, your next step should be to look towards implementing mutation testing. If you're interested in learning a bit more about what mutation testing is, how you might go about implementing it, then check this video out next. Or if you'd like to see some examples of refactoring and characterization tests in action, then check this video out next.